So the central conceit here is that the engine should not leak into the mission script. Um, Going back to my early thinking about a lot of this, bringing stuff into modules was a way to shield the API that I wanted to expose from the engine hooks that were allowing me to express that. So breaking the ties with the engine is a key part of this. And the early part of this is going to go over the existing trigger system and some of the problems with that, the structural cost, and how we're tied to the engine. And then what module encapsulation changes is going to be the second part of this. Should be about 10 minutes, including the demo, so plenty of time afterwards for questions or anything you guys need. The campaign API works, so this new module system is pretty cohesive. We still have gadgets, they're just relative to modules. Actions still do the same thing. They are events that tie to specific commands that the user issued. And we've got a huge surface area because I just kept going. I had basically a week here that I just had different modules that I needed to make Ashfall, the mission that I built, work, and that's kind of where we're at now. Don't claim to be an expert in any of them, but each trigger right now is just a wrapper over engine notification. So each trigger type wraps one engine notification, so the engine's behavior becomes the authoring surface. So our API is an expression of the engine, in other words. The same rule event can arrive several times over, or at moments that make no sense to a mission, when a unit changes hands, or when an unrelated visibility flag happens to update. Options that look shared or not. Triggers in the same family take the same settings, spelled the same way, and mean different things by them. Some events the engine never sends at all. Seismic detection is an example of this. Pings and nothing else. So no longer detected has to be invented with a timer and polling. None of this is carelessness. It's what happens when the boundary sits at the engine's edge. Every quirk on the far side of it becomes the mission author's problem. So the question this raises is either the API absorbs this complexity somewhere, or it surfaces every mission script that touches it. And the rest of this is a proposal for where that edge belongs. And I would argue modules. So here's an example of that. Actions are named by string. Nothing checks message rocks created. Exists until the moment it should have run. So it's all very dynamic and JSON looking. And this gives us ties upward. The mission can only name its trigger by reaching into a table the gadget builds when the game starts up. The mission file is therefore dependent on something that must already be running before it can even read. Downward, the trigger is a thin wrapper around one engine notification. So whatever the engine happens to do, including things it never promised and could change tomorrow, becomes the mission author's problem. The consequence is that seismic sensors hadn't detected or lost event at all, only repeated pings. So the API has to grow a timer and a memory of recent contacts to invent one inside that same growing script. And this compounds. So every time you add a new trigger that dynamically accesses this action in a new way, radar and seismic acts in a subtly different way now. They're not really exotic examples. So every time we add a new behavior, we kind of get another branch in our, to use a technical term, cyclomatic complexity. They also have loopbacks with the gadgets, so that's a problem. So yeah, that's going to get big. So now let's see a demo of it working. I have done a little starter base here. We are going to launch the mission editor and activate Ashfall from our list. Most of this you guys have seen already, so we're not going to worry too much about that. Let's go find our spawned units, which live down here. This tells things where to spawn on mission start. And they should be right around here somewhere. So as soon as we discover them, we should be handed the units through this trigger here,
captured,
which we can see has gone green. We have spotted the outpost command, give group outpost auto, protect outpost common until objective find enclave is complete. Important note, this is all just Lua, but we'll talk about that a little more later. So this is a language server that understands our game API that the game itself publishes. This has all the same stuff that the VS Code plugin has, which we'll see now. So if we go over here to our new Beyond All Reason plugin, which is just the language server running a Zero client framework that is also publishing into the game. So all the same stuff. You can see that it's getting real-time feedback from the game data directory and publishing it here. You can see that we built 3 out of 4 core LTs to complete this objective, etc. The enemy commander is alive. Okay. So this is basically just putting the boundary at the module. A module is a folder with a short file at the top saying what it is and what it needs. A short file, excuse me. Everything it owns lives inside it. Its scripts, its logic, the words it offers to mission authors, and its tests. And the list of things it needs is not a note for humans. When a mission loads, the vocabulary it is allowed to use is assembled from exactly that list. So a module's own words are available only when a module actually asks for them. And we could see that if we go over to the mission folder. And look at the module. This requires exactly what it needs. Match flow controls match in, combat controls combat, transfer controls transferring units. And all of these are just naturally exposed in the mission triggers. So if it doesn't exist in that list from another module, you can't write it here right now. We can go in and whitelist like math modules, I think is a good idea, but right now it is a strict subset of Lua. So that's important to understand. There's no leaking here. Because we have the language server running on the CI, we can just validate that this is in fact what we expect. It also gives us a way to do, and this is not in there yet, but we could do custom blocks. Like you could do something like custom and pass arbitrary closures to this. I almost typed do. Is do right? No, am I thinking blue? Anyway. And inside here, we could also get the same checking, right? So if we do have a subset of Lua that is expanded beyond this, we can allow much stronger checking of our custom behaviors because we have a parser in the loop. This graph right here is actually published by the VS Code plugin. So if we go down to reference, and it's all emergent, like we don't actually type any of this. This is just the language server's understanding of our module connections by reading the code, right? So as we add modules, this will naturally update, and we don't have to maintain any of this. The language server just gives us this because it is literally just reading Lua, and that's all it does. It doesn't have much functionality right now. Beyond that, we could always add like stuff in here that's like hints for our UI or something. If we wanted to add some features to the language server or any sort of meta information, we could do grouping and stuff through comments that would be a layer on top of our it's just Lua. But right now it's just Lua. No, Firefox is freezing. Oh yeah, I don't know why Firefox is freezing, but hopefully figured that out before the meeting. So game modes are a concept I came up with for transfer to encapsulate these different running experiments I had, but I realized it was actually just a global configuration object. It's a preset that allows a given mode. So let's say you click into campaign. That will give you a mode for missions that is setting up its own unit mod options that are locked down, what it owns in terms of like I control match victory now, the mission API does, while under this mode. And it's just a top level configuration. You get one per stack. So missions get a mode. You can have a different mode for transfers, a different mode for whatever, and that all comes from Chabi. So this is like the one artifact that crosses that boundary. It did catch a row one. It's caught a lot of row ones, honestly. Moving these into modules has a lot of like cognitive benefits in terms of how we group code into domains. Mission using scavenger ways would not arm, because those units are only loaded when something asks for them, and a mission asks for nothing. They're told the author to tick a box in the lobby. Now the mode asks, and there is no box to remember. It also comes off the wrong answer. The other way to get those units is a setting file that scatters derelict bases across the map, which works and leaves a map full of scenery nobody wrote. Part of that is just the fact that we're running inside skirmishes right now, but that will, of course, change by the time this releases. So everything's locked down by default, unless you unlock it, right? Difficulty and then list are two decisions a lobby is there to make. A small language and modules decide what is in it. So because this is a subset of Lua, we can't enforce that. We kind of already talked about that briefly. And it's deliberately small right now, but we can't expand it to be whatever the game wants without touching the language server. An author cannot reach around the API by accident, so this is a security concern. They can't do things like call random endpoints because we have this language server running in the CI. So each condition inside the module, so if we go over to the modules API exposed here, let's find a better example. Mission DSL. This is an example. They're all just closures that look very similar to the existing trigger system, but they're typed. And they track their own inputs, which is important. So is spotted depends on this unit entered LOS hook. So because we're tracking the inputs on the definition side of the module, we can form a abstract syntax tree, which is exactly what it is, that says, okay, this hook, whenever the mission script depends on it, I need to build out my state tree whenever this engine flag fires for that hook, that whenever it's in scope. So today the engine has asked to report 14 different kinds of event in every mission, whether or not a single trigger cares about any of them. And then under the new Ashfall mission, because it only reads what it asks for, at most 5 in each one, only while loaded trigger actually asks for it. Change the mission and the ones no longer needed are dropped. And because it's a closed vocabulary, the list of event names is closed and machine checked. 10 of them misspell one and the checker flags it immediately, instead of leaving you a trigger that quietly never fires. So let's see that. The language server is checking this all the time, right? So we do get live feedback here. If I misspell a unit def name, it will say, hey, the game doesn't publish that. And this is all just crossing over via JSON to the language server. A module extends the vocabulary without touching the runtime. The Waves module adds 4 new events and a set of new words for mission authors. Nothing in the mission system was changed to permit that. It simply takes whatever the modules it asked for and brings with them. So that was the require line that we looked at in the mission modules.lua earlier. And if 2 modules try to add the same word, the mission refuses to load and says which 2. Nothing quietly overrides anything, and nothing reaches into shared global. So there is no GG singleton lookup. Transfer was built for multiplayer. It is the module behind the sharing tab, governing what may pass between allied teams. It now supplies transfer give, which is how a mission hands the player their starting base. Not one line of it was written with missions in mind, and none of it had to change. So very important. The fact that we get crossover for the same behavior between multiplayer and single player gives us a way for those 2 communities to work together, contributors and maintainers. And let's compare the existing trigger system with its dynamic types versus the exact same flow in the DSL. So mission started, when match flow started, Outpost seen when this unit has been seen, and enclave found. Is right here. Protect the hub, which is encapsulated by combat. So instead of having a magic string that the trigger system knows how to unpack as this thing internal to itself, combat does that for us, and then the mission API just has to hook into that existing behavior. 2 conditions on 1 statement rather than 3 triggers chained by name. 6 names checked when the file loads rather than matched by hand across 2 tables. And keeping a unit alive is borrowed from the combat module. On the left, it has to be written by hand because there is no module to borrow from. Ashfall is 4 beats as written in the doc. The outpost changes hands. The first scavenger wave arriving, Armada Enclave, and the Tenebrium device on first sighting. This is actually really hard. That wave is huge. And then victory whenever you delete the commander. And importantly, this also works in multiplayer. It's the same exact code. So we switch on the scavenger AI, player to the lobby. A mission has no lobby and no slot to add one. So it names the wave pack directly, and the scavenger's module supplies it. Same director running inside an ordinary skirmish at 1/10 of the intensity. The editor is a view of the file, not a database. So 9 triggers across each file, 3 files, each rendered as a sentence. The editor does not keep its own list of what missions can say. It reads the same descriptions the modules publish. Adding a new word means editing that module and nothing else. Each one is read out of the running game next to the rule it belongs to. So in this screenshot, 5 out of 4 is the number of LTs the player has built, so it is over-satisfied on that trigger. Alive, the enemy commander this objective is waiting on is still standing. And then dashes just mean nothing to report yet. Checkboxes mean it's finished. It shows what's already happened, not what is true right now. A trigger that fires once would otherwise light up and then go dark a second later. The game broadcasts which triggers have run, and this panel and the endgame one read the same broadcast. The mission shape generated from the mission itself. So because the language server understands the module shape and what leads to victory, we can dynamically understand the game's own behavior and the connections between triggers at edit time. So 2 monoliths became a library, and this is talking about the scavenger stuff and the wave stuff. So we ripped out the scavenger's code that spoke to waves and made a separate module that was testable, importantly, and compatibility is enforced by the language server. So I think what we should do is have Boneless Dog Food this at some point. Like, he's already been working on the Intel module under the existing trigger system, so ripping that out and making a formalized API for the Intel module that does emit atomic events when we would expect would be a very good side-by-side comparison with a system that he's already intimately familiar with. We could also review the existing Fable take on most of these modules. I wrote parts of transfer, but other than that, this is mostly vibe coded. But it is the shape that I gave the system to work off of, so it does give a good representation of what the modules look like, and we can start to use this as a foundation to branch off of for other work. Okay, I think I'm going to play the game a little bit while you guys talk and ask any questions, and we can see me get my ass kicked.
Battle paused.